So welcome to the tutorial on solving systems using matrices. We have two objectives in this tutorial. We're going to be working with 2 by 2 systems, that's two equations and two unknowns. We're going to be solving them by hand by inverse matrices and by augmented matrices. We're also going to look at a 3 by 3 system, that's three equations and three unknowns, and we're going to be solving that by augmented matrices. So here we are in section 10.2b. And if we look at the following system, this is a 2 by 2. I call this a 2 by 2. It's two equations in two unknowns. It's all perfectly set up for both of our methods, meaning that the x's are underneath each other lined up, the y terms are lined up, the equal signs and these constants are lined up. We can solve this system using two different methods. If we first want to solve by inverse matrices, we need to know how to put this system into a matrix equation. So the first matrix is going to be a coefficient matrix, and it's going to be 1, 4, 3, and -2. That's the 2 by 2 coefficient matrix. We're going to multiply that to our variable matrix, which in this case, since our variables are x and y, we're using x and y. And we're going to set that equal to our constant matrix, which in this case is 14 and 0. So let's see where all of these numbers come from. This 2 by 2 matrix is called the coefficient matrix because the 1 and the 4 are the coefficients of our top equation, 1 and 4. The bottom row of this 2 by 2, the coefficients are 3 and -2 because those come from the bottom equation, 3 and -2. Now if you were to perform this matrix multiplication, this 2 by 2 times this 2 by 1, remember you multiply the top row by this column, so it makes sense that 1 times x plus 4 times y would equal 14, and that's your top equation. So that's where that's coming from, and similar, that's where the bottom equation is coming from. If we label this first matrix matrix A and this constants matrix matrix B, then our variable matrix, which is xy, will be equal to the inverse of matrix A times matrix B, and those would be our solutions. So we need to be able to find the inverse of matrix A and multiply that to matrix B. So the inverse of this coefficient matrix times this constant matrix. And it makes sense if you think about like an algebra 1 equation, something like 3x equals 12. To solve for the variable, we need to get rid of this coefficient. And to get rid of that coefficient, we could multiply by its inverse. And its inverse is 1/3. If we multiply this coefficient by 1/3, they undo each other and we're just left with the variable. Of course, we would have to do that on the other side and multiply this number by the inverse as well. So it's sort of similar to that. We find the inverse of this and multiply it to this, and we'll have our two answers. So we'll look at that in a minute. Using augmented matrices, we've already looked at an example of that if you remember the first tutorial of the year. So I'm going to go ahead and write the augmented matrix, and it's very similar to our coefficient matrix up top, the 1, the 4, the 3, and the -2. But in this case, we draw a little line, and then we put our constants 14 and 0. That's what the augmented matrix looks like. We have to perform a bunch of row swaps and manipulations with the numbers until that augmented matrix, where the coefficients are, looks exactly like the 2 by 2 identity matrix. And when we're finished with that, whichever two numbers end up right here will be the solutions for x and y. So we're going to do first by inverse matrices, and then we're going to do by augmented matrices. With a 2 by 2 system, I need you to do both of these, so be able to be proficient with both of these. So let's take a look at our first one. We're actually going to solve this equation, this system, both ways. So let's first start with inverse matrices. Let's first start with this method. So we need to write our matrix equation, which is identical to what we had just done, times our variables will equal our constant. 14, and 0. Okay? So, like I did in the last one, I'm going to make that matrix A and this matrix B. So the first thing I really need to find is the inverse of matrix A. If you recall from a previous tutorial, to find the inverse of a matrix, we need 1 divided by the determinant multiplied to that switched up matrix, DNA, negative B, and negative C, right? So in this case, we need to find this determinant, and that's our little fish guy. So I'm going to go ahead and write here and find this diagonal. The first diagonal, 1 times negative 2 is negative 2 minus 4 times 3. So I've got negative 2 minus 12. That's negative 14. So 1 divided by negative 14 is going to go right there. Switching this matrix around for the inverse part of the matrix, the 1 and the negative 2 are going to swap places. The 3 and the 4 are going to stay where they are, but they're going to become opposites. If you need a review of that, please go back and look at the inverse tutorial. So here is our inverse matrix. Now we need to multiply this. So we're going to have our variable matrix. We're going to take this inverse matrix, 1 over negative 14, times negative 2, negative 4, negative 3, 1. And we're going to multiply that to the constant matrix 14, 0. So once we perform this operation, we will have our 2 answers. So let's do this. I'm going to leave the scalar alone until the end. Otherwise, we're going to be dealing with ugly fractions. So I'm going to leave this scalar alone. I like to circle the row and circle the column. That's just helpful for me. So I'm going to have the 1 over the negative 14. And here's my middle step. I know that a 2 by 2 times a 2 by 1 is going to look like a 2 by 1. So I'm going to go ahead and put my middle step right here. So let's multiply. Negative 2, the first element, times 14 is negative 28. And then move across here to the negative 4 and down here to the 0. Negative 4 times 0 is 0. Add those together and we get negative 120 or negative 28. Now moving on to the second row, take the first element, negative 3, times the 14 gives you negative 42. Move across to the next element, 1, and down to the next element here, 0. 1 times 0 is, of course, 0. Add those two together, and we've got negative 42. One last thing to do, now we can multiply this scalar into this matrix. So when I multiply that into the matrix, a negative times a negative is going to be positive, and another negative times another negative is going to be a positive again. 1/14 times 28 becomes 2, and 1/14 times 42, it's divisible, becomes 3. So I know now my 2 answers, x and y equal 2 and 3. This is how to solve this system using inverse matrices. We're going to look at the same exact system, and we're going to solve it by augmented matrices. So here is augmented matrices. Same system, so some of these numbers are going to look very similar. So I'm going to first set up my augmented matrix, 1, 4, 3, negative 2. I like to draw a little line here, 14, and 0. Now remember my goal. My goal is to get the 4 numbers here, this 2 by 2 part of this augmented matrix, to become the identity matrix. And that is, let me get my eraser. That is not an eraser. There we go. And remember, that is 1, 0, 0, 1. That's ultimately what we need to get it to. Now, we want to go in a specific order. We want to start in the top left and make this a 1, which actually, we lucked out, it already is. Once this is a 1, then we move down to make this a 0. Once this is a 1 and a 0, then we move across to make this a 1. and then finally we move up to make this a 0. That's the pattern that we go for a 2 by 2. So again, we already lucked out and we already have a 1 here, so now our eyes are on this 3. This 3 needs to turn into a 0. And the only way to make a 3 turn into a 0 is to combine it with a negative 3. So I now need a negative 3, okay? I'm going to list the steps. Draw a little arrow. I know that row 2 is what's changing, so I start with R2 equals. Since this is already a 1, it's real easy to make it turn into a negative 3. I'm just going to multiply it by negative 3. Now, this is not going to change anything in here. Understand that. The 1, the 4, and the 14 are not changing. The only thing that's changing is row 2. I'm going to temporarily change these numbers by multiplying by a negative 3. So 1 times negative 3, 4 times negative 3, and 14 times negative 3. So I'm temporarily changing these numbers to become these brown numbers. And now I'm going to take, this was negative 3. I'm taking negative 3 times row 1, and I'm going to add those temporary numbers to row 2. So I like to kind of put them up here so that I can actually visualize them. Now I'm going to, I'm going to add now. Negative 3 plus the 3 becomes a 0. Negative 12 plus the negative 2 becomes negative 14. And negative 42 plus 0 is negative 42. So I've changed row 2 by multiplying row 1 by negative 3 and adding it, that temporary number, to row 2. So now I've got my 0 and some other numbers. Whatever happens over here doesn't matter. I needed to get this 0. So now I've got 1 and then a 0. Now my eyes are right here because I need this to turn into a 1. I change this to a 0 on purpose because now I typically will multiply this entire row by a number. Multiplication is not going to change my 0. I see that negative 14 and negative 42 are both divisible by 14, or rather negative 14, which is what I'm going to multiply by. I'm going to change row 2 by multiplying negative 1/14 to those numbers. I'm not changing row 1 at all, not yet, so those numbers are still the same. I'm multiplying each of these elements in row 2 by negative 1/14. That does not change the 0, but negative 14 times negative 1/14 becomes positive 1, and negative 1/14 times negative 42 becomes positive 3. We actually have one of our answers already because this row is exactly what it needs to be, so we have one of our answers. So let's not do anything to this row that's permanent. We've got the 1, we've got the 0, we've got this 1, now this needs to be a 0. And very similar to how we got this to be a 0, we're going to do the same sort of thing to get this to be a 0. I can get 4 to turn into 0 by making it combine with a negative 4. So if I get a negative 4 multiplied to this 1 and add it to here, this would turn into 0. Okay, so let me write that step. Row 1 is changing, and I'm going to change it by multiplying negative 4 to row 2 and adding it to row 1. So let's see what happens. Again, row 2 is not changing. We don't want it to change. It's perfect already. Okay? I'm temporarily changing the elements in row 2 by multiplying by negative 4. That's not going to change my 0. It is going to change this, and of course it is going to change this. 3 times negative 4 is negative 12. These are just temporary, and I like to put them there so I can see. Since this did not change from 0, when I add that to row 1, it's not going to change my 1, which is great. The negative 4 adds to the 4 to make a 0, and the negative 12 plus 14 makes the 2. Hopefully you can see that we are finished. We have our 2 by 2 identity right here, perfectly intact, which means that we have our final answers here. We know that x equals 2 and y equals 3. If you go back and look at your inverse method and look at the math that's involved here and compare that to your augmented method and look at the math that's involved here, I think that you can find that it's pretty similar. Some people are going to like the inverse matrices, some people are going to like the augmented matrices. I need you to be able to be proficient in both So please make sure you pause, rewind if you need to go back and look at these. I'm going to show you a 3x3 system, and we're going to do it by augmented matrices. And you should all be saying thank goodness, because if you watched that extension tutorial on how to find the inverse of a 3x3, wow, it takes a long time to do that. And if you haven't seen that yet, go ahead and do that. So it's good that we're doing by augmented matrices on here. Now, this is 3x3 because I see 3 equations and there are 3 unknowns. So the first thing I'm going to do is I'm going to write my augmented matrices. I need the coefficients of the top, which I see that the x has a 2. I see that the y has a 2. Since I don't see a z term, I must think that that must be 0z. I need an element for every single one. I see the x, the y, and the z, so that's 1, 1, 1. And I see on the bottom one a 3, a 4, and a negative 1 as my coefficients here. 3, 4, and negative 1. Draw my little line, and I put the 6, the 1, and the 13. Okay, so this is our big augmented matrix, and this is going to take a few steps. In fact, it should take 9 steps at most, because there are 9 things that need to happen in order for this to become the identity. Maybe as a visual, we write what the identity is supposed to look like. It's a 1, and then a 0, and a 0 underneath, okay? And then a 1 right here, and a 0 underneath, and then a 1 right here. Then we go back up and get a 0 above here, and a 0 here and here. That's ultimately what we're trying to get to. So my eyes are right here up on the top left. I need that to be a 1. Right now it's a 2, so that's a shame. But some of you might be saying, wait a minute, here's a 1. How about I take all of this row and just swap it with all of this row? And that's a perfect first step. That's exactly what I'm going to do. I'm going to swap row 1 and row 2. So row 2 is going to come up top, 1, 1, 1, and 1. And row 1 is going to become row 2. So that's 2, 2, 0, and 6. Row 3 has not been touched. Okay, so we've got my 1. Now we need to get a 0 here. We also need to get a 0 here. And in fact, since the steps to get this to turn into a 0 are very similar to the steps to get this to turn into a 0, I'm actually going to do both of them at the same time. It's not going to save any time, but it will save some space on our paper. Row 2 does need to change, and row 3 needs to change. So I'm going to have 2 different statements, an R2 equal statement and an R3 equal statement. Let's talk about row 2. If I need to change this to a 0, I need to combine this positive 2 with a negative 2. So I'm going to take this 1 and I'm going to multiply it by negative 2. That's where that negative 2 is going to come from. Now if I'm going to change this element, I need to change all of these elements the same way. And in fact, since they're all 1s, it's all going to be negative 2s up here. That's interesting. Remember, we're not actually changing these permanently, we're just changing them temporarily, and here they are temporarily. So I'm looking at these purple number negative 2s, and I'm going to add each of them to the elements in the second row. So I did negative 2 times row 1, and I'm going to add those elements to row 2. So let's start there. 1, 1, 1, and 1. That is not changing. Not yet. Negative 2 plus 2 becomes 0. Negative 2 plus 2, hey, that's another 0. Negative 2 plus 0 is is negative 2. And negative 2 plus 6 is 4. So cool. We've got our 1 and now our 0 right here. Very similar, we're going to be changing row 3. This time I need to get a 3 to turn into a 0. So I'm finished with these temporary numbers. This 3 now needs to combine with a negative 3. So I'm going to take this 1 again. That's why we have to make it become a 1 first. And then it's real easy to make it whatever number we want. I'm going to multiply it temporarily by negative 3. And again, all of them are 1s, so all of them are temporarily going to change to a negative 3. So we're changing row 3 by multiplying negative 3 to the row 1. and then we're going to add it to row 3. I like to put them up here as a visual so I can do my addition pretty simply. Negative 3 plus 3 turns into 0. Negative 3 plus 4 turns into 1. Negative 3 plus negative 1 makes negative 4. And negative 3 plus 13 becomes 10. So 2 steps in 1, and I got my 0 here. I got my 0 here and my 0 here. Excellent. So now, since I've got 1, 0, 0, my next thing, I need this to turn into a 1. I'm going in this order. And if you'd like to number the order that you're doing, you want to do this one, then this one, then this one, then go to here, step 4, and then here for step 5. Then go to here for step 6. Then come back here to get this to turn into a 0, 7, and then here 8, and here 9. Now a lot of times these two zeros can be done together in the same, and these two zeros can be done together in the same, you'll see. So that's basically the order, if that helps you. So I've got my 1, my 0, my 0. I need this to turn into a 1. And some of you might be saying, wait a minute, I see a 1 right underneath it. What if we swap this brown row with this middle purple row? That 1 would actually go here, and at the same time, this 0 would come down here. Wouldn't that be great? We don't want to swap this 1 to down here, because if we did that, this 1 would replace with this 0 and mess this up. So I see a row swap again. I see a row swap. I'm going to swap row 2 and row 3. It's actually going to kill 2 birds with 1 stone. Top row is not changing. I like to put that in first. So the brown row is now going to become row 2. So that's a 0, a 1, a negative 4, and a 10. And this second purple row is going to become down on the bottom, which is 0, 0, negative 2, and 4. Yay, we've got a 1, a 0, a 0, a 1, and a 0. My eyes are now looking right here. I need this to be a 1. This to be a 1. Well, typically in this situation, I look at this entire row and hope that it's divisible, which it is. I can just multiply everything by negative 1/2, and that's not going to change the 0 or change the 0, but it's going to change this to a 1, and obviously it's going to affect this. And that's what I'm going to do. Now I'm going to do that on the next page, so bear with me here. I'm going to try and copy this so we don't, oh boy, so we don't lose that. Alrighty. I'm going to the next page, and let's paste that. Yeah, because it pastes a lot of stuff. Okay. A lot of stuff that we don't need anymore. We've already written this down. Alrighty. So that's that. Okay, let's get this up here. Okay, and now let's continue. So we said that we're going to change row 3. Row 3 is going to be multiplied by negative 1/2. And again, you might be saying, why aren't you just dividing by negative 2? Well, I don't like to do division. I'd like to do multiplication. So there we go. The top row is not changing still. The middle row has not changed. The bottom row is all going to be multiplied by negative 1/2. That does not change my zeros, which is great. But negative 1/2 times negative 2 becomes 1, and negative 1/2 times 4 becomes negative 2. All that work, and we finally have one row already perfect, which means we already know what z is. It's going to be negative 2. Do not do anything to change anything in here, not permanently. So we got 1, 0, 0, 1, 0, 1. Now our eyes go all the way up to this. This needs to turn into a 0. And it's very similar how we got the zeros here. This 1 needs to be combated with a negative 1, and I'm going to get a negative 1 by multiplying this 1 by negative 1. I'm going to multiply, first of all, row 1 is changing, finally. Row 1 is changing. Row 1 is going to be multiplying negative 1 times row 2, and we're adding it to row 1. So row 2 is not changing permanently, so I'm going to go ahead and put that in first. Kind of helps me get my matrix together. Row 3 is definitely not changing ever again because we're finished with that row. What we want to do is temporarily change this row 2 by multiplying it by negative 1. That's not going to change my 0, but it is going to change this temporarily. and this to a positive 4, and this to a negative 10. I'm just temporarily putting them in here. And now I'm going to add these red numbers to these top numbers. The 0 plus the 1 does not change my 1. That's good. The negative 1 plus the 1 makes this turn into a 0. The 4 plus the 1 makes this a 5. And the negative 10 plus the 1 makes this a negative 9. So we're getting so close. We've got 2 more steps to do, but I can do them both together. We've got 1, 0, 0, 1, 0, 1. We brought back up here and got this to be a 0. Now we're looking at these 2 elements. We need these to both be zeros. We're going to use the one that's already here, and we're going to use it 2 different ways. So I'm going to go ahead and draw my arrow up here. I'm going to be changing row 1, and I'm going to be changing row 2. So I have R1 equals and an R2 equals. Let's talk about row 1 again. We've done this a few times by now. If I need 5 to turn into 0, I need a negative 5. So if I take this and temporarily multiply by negative 5 and add it to this, I'll get my 0. So I need to multiply all of these by negative 5. Well, the zeros aren't actually changing anything, but this is going to change to a 10. Because negative 2 times negative 5, of course, is positive 10. These are temporary numbers, and I'm going to multiply those and then add them. Let's see, row 3 is not changing. I can put that in first. Row 1 is what I'm changing right now. So what did I do? I multiplied negative 5 times row 3 and added to row 1. It's real important for you to do these communication steps so that people know what you're doing. Heck, so that you know what you're doing when you go back and look at this. Okay, so temporary numbers. 0 plus 1 keeps it a 1. 0 plus 0 keeps it 0. But negative 5 plus 5 makes that turn into a 0, which is what we needed. 10 plus negative 9 becomes a 1. All right, we are almost there. Row 2 is now changing. It needs to make this negative 4 turn into a 0. So it needs a positive 4. We're finished with these purple temporary numbers. Now we need to take this 1 and multiply by positive 4 so that that can combine with the negative 4 to make 0. So these are still going to be zeros because multiplying these by anything is still going to stay 0. But negative 2 times our 4 becomes negative 8. So we did positive 4 times row 3, and we're going to add that to row 2. Positive 4 times row 3 plus row 2. So 0 plus 0 is 0. 0 plus 1 remains 1. 4 plus negative 4 makes 0. And negative 8 plus 10 makes 2. You can see that we have our 3 by 3 identity intact, so therefore we have our solutions. X equals 1, y equals 2, z equals negative 2. That was a lot of work. So a 3 by 3 done by augmented matrices is what we just did. I know you want to take your hand at 2 of them. I've given you 2 try problems for you to try. Here's a simple 2 by 2. I'd like you to try both ways, solve by inverses and solve by augmented. Okay, and then here's a 3 by 3. I want you to try all 9 steps to solve this by augmented matrices. These are try problems, so at this point, if you could please pause the video, try them, and then come back to see if you got the correct answers. I'll see you in a minute. All right, thank you very much for trying these 2 problems. I hope that you had success with both of them. The first problem, your answer should have been x equals 1 and y equals 2. You should have been able to do that both ways. And the third problem might have taken you some time. You might have gotten stuck. You might have needed your eraser to go back and look at some of the steps, but your final answer should have been x is 1, y is 3, and z is negative 2. Thank you very much for playing, and we'll see you in class to practice this more. Bye-bye.